Welcome back to Cloud Computing and Big Data. Today we have our short lecture 14, Online Social Networking and Graph Databases. It is a short lecture because essentially you have learned almost all material already in the course. So we basically at the end of the course, and I just want to make some pointers here with the short lectures, which are actually topics which are very massive in content. So you can really have whole lectures just on online social networking, advertising, influencer marketing, etc. And on the other end, you also can easily fill a whole lecture series on graph databases. Today, graphs are used almost everywhere. So in lots of different contexts, even in the epidemiology, what we have learned from COVID-19 tracking of patients, of course, graphs were very essential in this. But before we go into the material of the short lecture 14, let us review a little bit what we learned the last time, where we switched a little bit the perspective. So the idea of lecture 13 on OpenStack was rather, instead of just using clouds on the infrastructure as a service level or platform as a service level or even software as a service level, here we turn around the view and we'll think about what happens if you are in your office. You're basically the expert for distributed computing and high performance computing in your company. And then suddenly your boss comes to you, I want a private cloud in my company, realize it. And then you have, no big question marks because OpenStack exists. So if you want to do your own cloud in-house, OpenStack is basically providing you with all the different Lego pieces and building blocks. Essentially, you need to create your own cloud. Of course, you have to configure, you have to pick the different pieces, you have to bring it together to form it what you essentially need, of course. But in general, it's like a big, let's say, collection of Lego bricks again, where you can build your own cloud. And this has basically different facets. We know already our own cloud could be something like this, following the ideas of the public clouds of using it rather bare metal. It basically, don't have anything installed, no virtualization and so forth. Using it maybe with virtual machines. So you provide maybe some images, VM images based on deep learning packages, but could be also on some other, let's say, computational fluid dynamics images, what we learned also in the Uber cloud. Or you go the whole way and thinking about containers, what we had in the previous lecture on lecture 12. And if you remember, the containers were very much enabling microservices deployment, which is a little bit independent from operating systems, which makes it very, let's say, slim deployments, which is also shown in the graphic here, a little bit illustrated in that. So it's much more flexible deployment. Also, let's say, less space. If you know and remember, virtual machines always carry around basically the guest operating system. But in the end, it doesn't really matter what you want to do, because OpenStack can be actually realizing all of those or a combination of those, of course. And of course, because it's in your hands, you are creating this cloud. There are no boundaries. So you could start maybe with doing it with bare metal or virtual machines. And when basically this is established, at some point in time, you introduce containers to your company. It may be even good because you have a learning curve with this. But of course, you have to really think where your demand is going in the company. An example is that you maybe want to use parts of the Uber cloud and these containers that we learned there, already very much optimized for engineering problems, as we learned, for instance, for CFD with ANSYS packages and stuff like this. And you want to be interoperable, then you have to go the container way. Or you want to realize something like we have seen in Amazon AWS AMI images. If you remember a little bit, these were filled with PyTorch, MXNet, TensorFlow, and so forth. Also deep learning packages with the right underlying libraries like Nickel, which is very much optimized for NVIDIA cards and GPUs to really make deep learning quick and fast. But in the end, it's of course very flexible, and hence this lecture, what we had in the lecture 13 was really showing you just a rough overview. What could you realize with this? We learned that OpenStack is one of the most thriving communities in open source software today. You will find lots of seminars, you will find community events, and many different blueprints how you can actually realize with OpenStack your own cloud. Of course, you can imagine it has always a three kind of elements you see here: the compute, networking, and storage. And you have this OpenStack shared services, which are in the end very important. You have an API to your application of sort, or have an overview with a dashboard, what's happening, monitoring all of these services. But of course, one thing should be pretty clear. When you do your private cloud in-house, you have to buy hardware resources. They will not come somewhere out of the nothing, right? So of course, here it's clear that you have to go to your boss and say, yeah, we have to buy physical infrastructure for it. Please put that in your budget. And this could be also something where you just want to combine that with public clouds. We see that incredibly often in practice. So people have sensitive data, want to have a little private cloud. And for the public cloud data, you can do this in AWS, MS Azure, or Google Cloud Platform whatsoever. But, you know, basically what I'm saying is don't underestimate, of course, that you then are also in charge of the hardware infrastructure, which is below this OpenStack. It's not really shown here very much, but you can imagine that, of course, storage, compute, network, just virtually as software doesn't mean anything. You have to buy the proper networking interconnect. You have to buy the GPUs if you do deep learning and so on, or CPUs if you do other problems for optimization or whatever it is. And of course, somewhere the data needs to sit. So you have to have hardware resources and storage underneath. And then the same problems apply. We learned earlier in this lecture series when we think about, okay, now this is requiring also lots of maintenance. But without going too much into detail, because this is just a short review, you had lots of different basically services which reflect what we have seen in AWS services. For an example, virtual machines can be used with Nova, the container services with Sun, and then you have in the networking side and also on the storage side and so on. You have essentially very much mirroring these services which you have seen in AWS, and you can go on and go on and go through the other service portfolios. You will have the same basically reflection of how you could realize something like an S3, maybe with Swift here, which is an object storage if you learned in one of the lectures, or you go for Cinder as a block storage and so on. We also have seen that this is tremendously used. So Blizzard was one of the big companies for gaming industry, which is actually using this. And also what I wanted to pick then in the last lecture really specifically here and there was this kind of really interesting features. And one of that is really the scaling behavior that we know is in cloud computing, one of the selling ideas. So that you, of course, think about scaling with the load of your services or the load of your players in that point of view. And here we see that basically in this graph very nicely that everything is monitored, of course, and it gives you the infrastructure to do so in OpenStack. So you can really monitor your users, you can monitor what's happening on the storage side, on the compute side, and so on. And then you basically, with this auto-scaling, what we have heard by using heat and send-in and so on from the last lecture, we see we basically can do auto-deploying of really scaling up with your requirements, basically when it's everything, you know, getting to more users. But of course, with that, you also have the other way around of saying scaling down, right? And this is an important factor. You're saving costs, you're giving free space for other games, maybe, because if you remember, Blizzard has not one game, it has many different games to have this on their gaming service these days. So it's a constant, let's say, looking at what is the load of the service. Can I create virtual machines? Can I delete or remove virtual machines from my service in order to essentially give free space for other people to use this platform better? And with this, you enable load balancing also indirectly of having much more service available for those games which are maybe very much hyping in the moment, while some other services maybe don't require so much resources. But this was essentially the last lecture, and in the end, I would say it was one of the most important in the end substance lectures we have in the course. As I said earlier, we come now to a domain where it's conceptual, theoretical pointers really to much more content, to much more interesting elements. And the online social networking world and the underlying graph databases, which is enabling it, is of course an extremely rich field. And year by year, when I'm teaching this course, you could say that, you know, you have much more in this area to show, to actually basically share with you. But it's not that I can integrate more and more lectures here. So we basically at the end of the semester, but I still want to give you some pointers to what you should study if you're really seriously interested in this field, and give you some pointers what is important and so on. The same goes actually for big data streaming, where we also have a short lecture, because streaming is getting more and more important. We cannot keep all the data. The sensor is getting extremely good. And with this, our petabytes are just growing in the archives. So the question is actually not what to keep, so what not to keep. And streaming here and there and analyzing the streaming that comes in is, of course, an important factor in that. But this will be the next lecture, just basically coming a little bit to the conclusion of the course here, was having, let's say, 2 more short lectures and then an epilogue, which is very, let's say, more an informal lecture reflecting on job skills and so on. So today, as I said, also it's really a disclaimer I have to make here. So from social graph traversal and alone graph theory, it would actually fill 3, 4, 5 lectures. Learning all of this is not the key idea of this course. Basically, there is really room enough for a course completely on graphs and so on. But still, it gives you pointers, and we will look a little bit on this in terms of Facebook examples. We will learn why is that such a profiting business. So we look into advertising, promoting it. And these are many things you know, which you have seen. When you go to Facebook, you see the advertising. When you go to YouTube, you see the advertising, and so on. But they will also switch sometimes the perspective, and we'll go then and think and analyzing what can we do in order to advertise and promote. Of course, as a conceptual lecture, we look a little bit behind it. So what is essentially the 6 key functionalities, if you want, with some examples of this online social networking and why it's so relevant to have the social graph traversal. And this term is not obvious to you. We will see how that materializes when we come to that. There are different architectures. Some of them you know already from the Graphx library we had, basically based on Spark, which you can essentially execute on all of those cloud systems which actually have already a Spark infrastructure like MS Azure we have seen. And then I come to a very short note on a AWS Neptune service, which is quite interesting in that context, supporting graphs in AWS. And to show you then a little bit here and there some directions and which areas you should do more research if you're interested in this. Of course, you can go to totally theoretical approaches. Graph theory is very interesting. It gives you lots of good insights, and it's reflecting lots of basic computer science. So you have essentially, there are lots of interesting performance wins when you do, let's say, more graph-based approaches than just, let's say, normal table-wise approaches. We will reflect on this when we look on some Facebook examples, and then also think about how actually people using the cloud and why influencers and marketing are a big thing today. I'm sure you noticed that already. We will have a very interesting single Pringle example also in one of our videos later. So online social networking advertising is on vogue today, perhaps more important even than websites. So having ads, connected in Facebook's, bought in Google Ads, and then of course you basically do the other way around with AdSense, and we will see what the difference is there. This is a huge market these days, and while you think Facebook is free, of course, never forget that their promoted content, where they earn a lot of money of people, either promoting their pages, promoting their products, whatever it is. But there's of course a revenue stream, a return of investment of all of this. Even if Facebook is free to subscribe, let alone the fact that they of course earn lots of insights from your data. Of course, on top of it, they have this advertising business, which is a big thing and can be very costly for companies. But the big win is, of course, with the social graph in between and basically underpinning Facebook and many other social networks. Of course, you really reach a very good audience that maybe otherwise would be just bought with 10,000 addresses that may or may not be interested. And here in the social graph, usually Facebook gets the advantage of really can understand lots of the interesting elements of their users, and with this can have targeting, basically advertising campaigns, and so forth. It's a very rich field. Today, even it's a job profile, you would say social media manager. Is this the domain we're talking about? But of course, I want to connect it a bit more to the aspects of the course with cloud computing. But more and more in the last 5 years, we have seen that this becomes very much intertwined in many ways. So it's an interesting other area to study. So let's understand online social networking first. What is the connection with graph databases and so on? You can imagine this basically this big data that we know already with ebooks and video streaming and so on is there in big data, but social networking is maybe more and more growing and will be in the future one of the biggest big data elements. Of course, we learned satellite sensors and they are growing also. And here it's just the sheer amount of interesting data which is not really homogeneous, right? So in a way, you would say it's really something which grows very in all sorts of directions, which you see, and it's not really predictable, as you would say, right? And this is a very important thing that is, of course, really noticeable in online social networking. I said earlier also in some of the lectures, some people share all the images, the pictures, some just, basically every year get some birthday wishes and greetings, and that's it. So there's completely different behavior in the people using this online social networking and sharing of content creation, linking content, and so forth. And with this, it makes it really interesting as a source for big data, really, that is constantly growing in size and is definitely a little bit unpredictable, which is the interesting thing, because, it reflects how people interact. You never know how that exactly is turning out, also reflecting to what's happening in events in the world, particularly the COVID-19 pandemic, you can now see probably has changed the way we use the social networking tremendously, because we never have contact anymore. We don't go to our companies, we don't go to our research organizations, sit there and then basically talk with our colleagues. So we have to use maybe social media to connect to people and so forth. So here are some examples of those, and you can imagine, I think everybody of you knows these services, and this has stood the test of time. I wanted to make the case because it's quite an old reference. Here and there you will say 2017 and so on. I just wanted to make the fact that still this is very relevant. You would see YouTube is maybe #1, but in the end, Facebook, YouTube, and Twitter and so on, they are very much in the front of all of these big data sets. And LinkedIn becoming more popular is getting increasingly used. And Google Plus probably has much more people, and Tumblr and Pinterest. There are lots of these around. And I'm sure you noticed that Instagram in the end is Facebook again, just with a specific, sub-product, and of course also extremely popular, if not one of the most popular today. In the end, it doesn't matter exactly which one I'm talking about, but you see the sheer amount of, monthly unique visitors. This is something which then reflected is in a very interesting graph network, right? So all of those in a way share content and have content linked to people or products or services. So things which is interesting to notice, because here we leave the space of this typical, structured query language, SQL databases where everything is predictable. Always give me your name, your surname, and then your telephone number and your address. That's not what we're interested in anymore, right? If you share something in YouTube, nobody asks about your address. So you basically share content and you link it probably, and basically cite someone, or on Twitter, you see @something tag to actually either tag a friend, or you tag a company, or you tag a product, or whatever it is. So speaking of which is then this huge network of interconnections, which is a bit reflected in the data set you see here. So very much unhomogeneous, very heterogeneous, growing in all sorts of directions. And here you see an example from Facebook, how that looks like. You can imagine that you have certain users, and actually they have a friend of a friend and a friend of a friend. So they are all connected in this kind of node and interconnect or link, and in a graph that would be kind of the idea to have this maybe directed or not directed, but here you have a direction that is, this is a friend, this friend, and then you can imagine there's this kind of relationships to each other with likes and liked by. So essentially you can imagine that Facebook looks a little bit like that, right? You have entities at this nodes, and then the nodes in this big, mesh up here of this big graph is then really the thing that is getting interestingly connected in all sorts of directions. So when we look at these characteristics just a little bit, I think it's a bit conceptual, but that's how university lectures are sometimes. So we have to look a bit on the complex set that we have there. So it's this kind of interpersonal relationships along many members, societies, communities, products, whatever it is. And essentially the social and professional relationships is reflected in this network, and also buying behavior maybe of products or rating behaviors here and there. And you could always see that there's this kind of two entities, or basically one entity really, which is a node, which reflects organizations, products, really abstract entities. And then you have these ties or these edges between the nodes, which of course are the relationships you already know. So you like something, and it should be liked by, and you should be traversing this interesting, big, huge graph very quickly. So this is important to know. And I think from in one respect, I talk maybe too much about this. You can see when I go back here, all of those different social media sites, whatever it is, they have a similar structure of sorts, which is essentially something you already know. And I picked the example here on Facebook. I think it's very popular in Iceland. I have even seen grandfathers and grandmothers using Facebook here, which is in Germany, for instance, not so much the case I found personally. I think definitively there are people using that in this age, but I would say it's perhaps a bit more used here in Iceland as an example. But that's not the key point here, just saying like Facebook is a good example of how that works in practice. You have a very free sign up. You always have to remember when I say donate your data, that of course all your data is shared there, it's analyzed constantly. So in a way, it's not really free to join there. In a way, you donate your data there. So in this sense, you give your data. And then when you do this, you have to also, of course, think about that when you go there, you see always this ads and so on. And this is a big business, right? So you see that the Facebook gets lots of avenues through these ads, which are here. They're basically there. You see here, build your business. You can actually pay for certain ads. Here's an example from a big data tips webpage. I often cite here and there because it's short, interesting facts about things. But here you can then see how this ad would look like when you do this big data tips. And then you can also say what should be the total budget to display it. And here you see you've already paid 10 euros and 2 euros a day, which is not much. But if you think now a company does it maybe on the much bigger scale with $1,000 or €1,000 a month and more. And of course, you have seen the numbers from Facebook. They have millions, billions of users. So with this, all these revenues become, of course, tremendous to Facebook, which is an important business. You also see that there's lots of interesting things that you can analyze, how many people were reached, what would be the probability of link clicks to that page. And in the end, you also can integrate this nicely here on the web page to have a link on Facebook directly to become a Facebook friend, which is one big part of the story. Of course, on the other end of the scale, you of course think about security elements. We already had privacy issues. You have here examples of friends which don't give really their name, they don't give really their image, they're very shy. And with this, of course, the usage is really, as I said, very heterogeneous. You never expect exactly what will be one user sharing, what not. Here you have big data tips as one page in Facebook being very open, while one user may be very close and have not much content. I encourage you also to look this movie here, The Social Network. I think it gives you interesting insights, also basically indirectly related to the course. Now, when we look behind this, it becomes more of a communication tool. So we had very old tools they called bulletin board service, which maybe some of you don't even know existed. So dating sites and job hunting sites and so on. But they always were very group structured. So there was already this online communication for this particular group, and that's it, right? There were always quite boundaries between the different groups. So you always have to join the specific group. Now, in the online social networking world, you have more services character. And of course, it's operated as a software as a service, but much more within these services, you have much more services inside. So it's a bit hard to reflect on the services, what I meant here. But you think about that, you're basically not doing any more on the boundaries. It could be that dating, job hunting, liking products, doing the advertising, it's all so intertwined with each other by, for instance, using Facebook. And you can join groups and then share content from groups on your personal website. It's not anymore maybe, the concrete boundary of some certain websites. So with this, you think about it more as an individual oriented communication tool, which is one of the social network characteristically, which is very much on vogue today. And I think many of you will know this very much, particularly also in the light of the fact that these are more and more also offer you instant messaging tools, right? The Facebook Messenger was one of the first where you just, talk and, chat with all people on Facebook. But now we also see that much more people actually really using these services on a daily basis. And with this, of course, they be integrated also in many other different products. Now, when we look on the key functionality behind that a little bit, we have a profile page that's obvious to you, showing eventually all your information. This is heavily depending on the basically people that use this profile page or create this. We know already the content can be interestingly different. And then the second functionality part that we have is really the social graph traversal, that you very quickly can, have this user's friends of a friend, that you have access control settings by users. And this, based on a graph structures, makes it high performant. Because if you want to like something, you want to have it visible directly. And also if you're liked by someone, you want to know directly. It's not that you want to know this in 3 days when they have used the data and mined that and actually displayed that. In other words, it's a very high performance data structure, this graph. And of course, the social graph traversal enables you then to really quickly make the usability of things like Facebook, things like YouTube really real time to see the likes directly. And likes, of course, are just one example. There are many others like reviews and whatever. So the certain ingredient is always a kind of sort of communication and marketing aspect to those. So there is this Facebook Messenger idea of sending, public private messages among one friend or several friends, groups of friends. This instant messaging is really a very important part of it. And basically this public message board, when you think about what you write on your wall, I had a run this morning. This was very nice. And just to share the interesting pictures you did on a run with your friends or your family, that they know a little bit what you did in the day, if you're in different countries in the world. So this is all something which is, of course, understood. We know all, and by now, that we're all using that in one way or another. So this is a key ingredient as well. So with this, there's lots of content created, and this could be leading to the next kind of key functionality, which is really shared information and access control. Basically something where now the control is on you. So how much you actually share from your vacation photos, when you have videos from certain events, what do you do and link to your profile page. But this is how basically Facebook operates in these online social networks in general, right? In YouTube, the same way. Do you go live or do you upload the lectures? Whatever it is, this is a very important factor. It's sharing information with other users. Otherwise, this would be not so successful. Nobody can like your content if you don't share it. So this is another key functionality. Of course, these days, we have learned also access control is an important factor, which means security, who is actually seeing what content, you know, and you can look more in Facebook and, you know, look in the configurations, who is allowed to see something, which is much more elaborate than maybe Twitter, for instance, which is much more open in general, but also having just shorter notices. And then we see also more and more the integration of APIs like games, calendars, and so forth in these different online social networking apps. So the Twitter example, just shortly, you have a simple profile. It's my personal profile on Twitter, a bit outdated, so there's some new numbers here, but in general, you see the same principle applies through time. Then basically the people can follow, and they basically have the followers list, and it's all visible without access control. You can always see who is following me and things like that, and I can see who is following others. Communication tools, private direct messages is possible, so you can just, you know, talk with me, or I basically do this with the public and basically put content here. Shared information, I think this is very clear. I can, you know, post my YouTube lectures and say, well, look at this lecture, put it on YouTube, or things like that, which is directly to some other social networking, you know, others online social network connected, which is quite interesting in that respect. Access control here and there, looking on what is in the message timeline, what allowed for what levels of users, private, public. And there are different APIs really in Twitter existing to, you know, connected to extremely different content, things like buffer, which then automatically give you some new feeds, schedule feeds and stuff like this. But I mean, this is just a short example of Twitter. And you see that this really works. Here's an example of one of my workshops in the past in 2016. So you see it's already used since many, many years, Twitter successfully. And it enables, you know, kind of micro blogging if you want. It has always 300 characters limit, and you can nicely search in Twitter usually. And it gives you really a very quick update on the community. And you see a little bit how that works here. So you have an indexer that really looks on all the stored files, that gives a database, and then people can search in this database because its index is very quick. And essentially, if you want to crawl here the Twitter API and look on what's happening there, of course, I have to say there are lots of public tweets, but also there's a specific API they can buy access to, which basically has then the whole stream of Twitter tweets. So it's a big business market, of course, these days. Now you can imagine this all gives you big data. I just pick here basically the social graph traversal really as very, very specific social links or networks we have to look at. And the others is pretty much known, share music and photos and videos and so forth. So these are just example of this online social network services, which you already know from practice. So I can be a bit quicker here, I guess, looking a bit on the idea how that now fits into the Facebook idea. For instance, they have the social graph where profiles, tags, and relationships are in. And you see it's just one part of the database. There are different, let's say, elements to the whole Facebook infrastructure. And this is just one little piece of using it. In earlier lectures, we have also learned for indexing and so on, HBase is used. So this is an important factor where Facebook is actually using this concept. Now, when we go to this database idea of Facebook, it's a so-called TAO database, which is essentially, again, coming back to the failure idea. It actually assumes failure often. It's so-called the associations and objects database, TAO for short. And it is really a geographically distributed server cluster underneath. It has billions of read requests to digest with Facebook. So it's a very strong service, of course. And interesting enough, they also basically here and there have some publications, how they work. So if you are interested in that field, it's very important. But it's also good to know that, I mean, basically, of course, it's not the only database they use. You know that from previous lectures, NoSQL databases, Cassandra HBase are also used in different application areas from Facebook. And now when you look at this, it's a very much, you know, graph idea. And this is a key technique these days. This is would fill a whole lecture series of just going through this and working with these graph infrastructures today. and you can partition them in smaller subgraphs and so forth. It's a very strong idea of working with lots of information, which is, as you see here in these different subgraphs, something where you never know exactly how the graph will be evolve over the future, because you have always this inhomogeneous or heterogeneous growth of data. So in the example, you already know how the comment and like is to be stored. I reflected on this already, and that's what they do. Essentially, you see the entities of a typical graph here a little bit in the area of how Facebook is using it, by using it here with this kind of relationships and the nodes between it, like likes and authored by and things like that. So this is really a powerful database. And of course, you can imagine now there's huge ideas also how you could use maybe the Graphx database in Spark. It's another example of a graph database for different areas. We have seen it in one example of working perhaps with this top 20 pages and this, search algorithm and giving the different, let's say, ranking on web pages. This is something what we had already very early in the course. And it's also, of course, a huge topic. We have learned already in earlier lectures that we can nicely use this on Spark infrastructures using maybe MS Azure HD Insight or essentially Google Cloud Proc. There are different ones available that actually reflect in this open source tools where you nicely can directly use this graph tools. Also here, and you have seen in Amazon, of course, when you have this Amazon Elastic MapReduce services, we talked in one of the lectures that essentially Spark would be, there's something to think about in this area, and then you can have used, Graphx on this. But in the next lecture, we also learn a bit about Kinesis and the streaming data, which is also in the Amazon portfolio. Another interesting but large area of having strong services. Now, also coming to this graph database and the relevance, you see these days there are different types of graph databases usually used, like the knowledge graph you see here, or perhaps an identity graph, which is very interesting between different users, websites, and so on, based on cookies. And there, people using this tremendously. You can imagine Netflix here as, let's say, one of the streaming providers for movies and so on is using it. And it essentially enables you to create in the cloud very much fast graph queries based on this Amazon Neptune, which is, let's say, a graph database that really has the same idea we just discussed with entities and relationships, right? So that's nothing else. It's just, basically all prepared as a service already, so that you don't, create your own service. You can maybe use one of those. And there are also open source tools which enable you to use graphs in Java in different programming languages. And there are different uses of this. The knowledge graph and the identity graph are just good examples for this, where you have a real-time personalization, advertising, maybe for targeting, that you see a little bit here, and how that is used to know everything about a customer on different devices, cookie tracking along different devices, different websites. And by doing this, of course, you can directly get this advertising targeting that you already know. Of course, you go to the websites these days with advertising, you go to different services, and suddenly you see things you're interested in because you're tracked in the internet significantly. The knowledge graph is more a way of dealing with knowledge in big data. So not really personalizing necessarily, but just thinking about you have a huge amount of information which is really interconnected maybe in this idea of entities and relationships, how you deal with it. And you can extract that maybe from a typical data set and then put it in the form of a graph to easier work with it. And this is something which is reflected a bit here in this by having, different data. You do entity extraction from all sorts of different, let's say, data sources and all sets of different storages you see here, Amazon S3 or Object Store, we know. And then the Amazon Neptune just provides this data as a knowledge graph, provides the data differently in a different data structure to make much more faster queries. And this could be, with Elasticsearch or your different applications in different areas. But they all work the same way in essentially this graph traversal. At the end of the lecture, just wanted to give you a little bit hands on, the return of investment, the advertising and key functionalities, the visitor rate, you already know. Many of these things, I think, practically applied by you every day. The loyalty, high customers, having always, basically the idea of liking pages. And you can use this with advertising. So actually all this information you can reuse actually with doing advertising on Facebook. Of course, you have to pay for it, promote your page, and this is one of the revenues of Facebook. But you can have very targeting advertising here from 18 to 65 as an example, all genders. And this is a business model, which is, of course, it adds to additional revenues that you would have usually like subscriptions or premium content. Now you can also do advertising along the side. And some of you know that already. There's Google Ads, which really enables you to create ads for Google. You know exactly the keywords, you know what people are looking for. What are the keywords with big data? You see essentially here, these are very popular, and you know, essentially you see how many are actually using this and searching for this monthly. So this is of course the data that Google has from the search and from other tools that it offers to you to make your Google advertising much more targeted. And this is a big, let's say, a stream of funding for Facebook. AdSense is then the other way around, where you basically can put that on your different websites, on your YouTube, where you have essentially the idea of thinking about you know, the different ideas of how you integrate this in the websites. Here's this big data tips again, where you have this kind of frame that you put in. Here in Google AdSense, you can actually put that in and then create revenues for everybody coming to your website. Of course, it's just a couple of cents, but if you do this a lot and have, let's say, more and more content, then chances are this is really incredibly getting to you, basically to some nearby income. The key message to take away is really content matters. You always have to have content. And then, of course, when you think about YouTube, then really earning money for it, it's not so simple. You need lots of subscribers and many watch hours to do so. It's not so easy to really start there. But in the end, you can imagine if you have more content, it's more people subscribing, then basically you have also more watch hours. And with this, sometimes the revenue kicks in. So hence you see all of these are cloud topics where revenue models are very large. We have application areas of all sorts of directions. This is nicely reflected in this graph, but also some of you know LinkedIn is quite nice, for instance, for the job market, for professional, let's say, elements in your career. We as research scientists have, for instance, something very specific for research, which is called ResearchGate. So you can see now there are different, let's say, flavors of the social networkings, very much specializations really for different topics. And this is, of course, a huge market for cloud computing in the SaaS area these days, which is tremendously used. And perhaps everyone by you in class, I would say, is using one or another. If it's not just YouTube, probably also Facebook or probably Instagram. Right, but I want to close now with a short lecture because we basically have our time already used, just with a very small, extremely popular example, and also something that some of you already know with the influencer marketing, which has a big impact now in social you know, media, in online social networking. And let's look a little bit on this video. It's a very short video, and then we close the short lecture.
A Ripplelinks campaign.
Valentine's Day is a date marked by love and by brand managers alike being a special day that resonates with India's youth. But instead of focusing on romantic love, Pringle as a brand read their audience and declared being single is cool if you're single as a Pringle. Pringles is all you need, and a campaign was executed with Facebook and Twitter influencers. Viral Facebook pages and hashtag single as a Pringle trended on Twitter. Then overnight, a wink changed the world and India went crazy for Priya Warrior. Through quick adaptive thinking, the campaign put Priya Warrior front and center and created the next chapter in her story that she was as single as a Pringle. A collaboration with Priya Warrior fit perfectly into the brand's tongue-in-cheek campaign, winning over millions on Valentine's Day. The value of the collaboration with Priya Warrior increased in real time, as on the day of the campaign, her follower count grew 500K. The collaboration was able to capitalize upon the nation's sentiments, making the campaign instantly newsworthy. And the results were phenomenal. In just 2 days, the campaign garnered a reach of 7.5 million and 40,000 plus conversations. The viral Instagram post received an awesome response with 1.4 million likes and 30,000 plus comments. The campaign was well received digitally and got organic PR coverage in over 15 publishers. It was appreciated by digital gurus across the web. And to think, it all started with a wink.
Right. As usual, the disclaimer, I'm also not paid by Pringles, as you probably know. But I think it reflects really in 2 days, million followers and things like that. It's incredible what that could mean for, advertising campaigns, what that can mean from products from zero to hero, just by having the right, let's say, marketing campaign, which would be otherwise unthinkable without online social networking. If you do this in print and just give it in your city out somewhere, or basically even in a region, you would never have that reach in terms of customers, in terms of use, and so on. Interestingly enough, this is about singles, what I personally would not recommend you to stay. Well, that's about you. I would say Family Life has really very good things to offer. Also here, a disclaimer that should nothing reflect what I would say, but it's a very perfect example of really how that could work here by using the cloud computing with this online social networkings and then this marketing and ads. And that's all what I wanted to leave on the table for you. It's a little bit longer than usual, but just a couple of minutes, so I'm sorry for that. But I think it shows you different pointers to all the different directions in this area. And if you have interest to basically dig more into that, I encourage you. I think all of these fields are very interesting. That's all for today, and we continue with the next short lecture 15 on Thursday.